Hello students, in previous class we discussed about propagation of sound and observing the movement of vocal cord during speech. Today in this class we are going to discussing propagation of sound in different media. Let us try to know how vibrations can propagate through the different media. So what is the meaning of media we discussed in previous class? So the solids, liquids and gases that are acting like a media. So now we will discuss about observing sound propagation in solids. Strike one end of the table and ask your friend to listen to the sound produced by keeping his ear touching the table at other end. And also ask him to listen to the sound by lifting his head slightly from the table. So strike one end of the table and ask your friend to listen to the sound produced by keeping his ear touching the table at the other end of the other end, and also ask him to listen to the sound by lifting his head slightly from the table. So here figure 11 is there, no? Okay, like that do. Okay, so ask your friend to what difference he noticed while hearing the sound when his ears were away from the table and touching the table. Next, take a metal wooden strip, strike it at one end and ask your friend to hear the sound by keeping his ears at the other end of the strip. And ask your friend what difference he noticed while hearing the sounds when his ears are away from the strip and touching the strip. Means here take a metal or wooden strip, hold the metal or wooden strip with your hands as shown in the figure 12. Strike it at one end and ask your friend to hear the sound by keeping his ears at other end of the strip. Okay, and ask your friend what difference he noticed while hearing the sound when his ears are away from the strip and touching the strip. Do you know how to make a toy telephone using a teacups? Take two paper cups. Make small hole at the bottom of these cups. The hole should be very small so that only a thin string can pass through them. Now take a long string. Make sure that the string does not have any knots in it. Now push the string through the hole in one cup of the cups. Hole in one of the cups and fix the string by putting a knot at the end. Push the string through the hole in one of the cups and fix the string by putting a knot at the end. Similarly, fix the string to the other cup. Our phone is ready. So to make a toy telephone, take two paper cups. Make small holes at the bottom of these cups. So the hole should be very small so that only a thin string can pass through them. The hole should be very small so from that a thin string can pass through them. Now take a long string. Make sure that the string does not have any knots in it. Now push the string through the hole in one of the cups and fix the strings by putting a knot at the end. Similarly, fix the string to the other cup. Okay, so our phone is ready. You and your friend can communicate with these phones now. Stand away from each other so that the string is tightly held. Okay, so your phone is ready. You can communicate with your friend with this phone. So stand away from each other so that the string is tightly held. One of you can speak in the cup while the other can listen by putting the cup on his ear. Okay, so you speak from one cup and ask your friend to listen the sound with the help of another cup by keeping the second cup at his ear. Okay, are you able to hear the sound? What is the medium between you and your friend which is responsible for the propagation of sound? In these activities, you observe that sound travels in solid mediums like wood, metal, thread, etc. So are you able to hear the sound? Yes, we can hear. So are you able to hear the sound? Yes, we can hear the sound. What is the medium between you and your friend which is responsible for propagation of sound? The medium is thread. In the above activities, you observe that the sound travels in solid medium like wood, metal and thread. So here we discussed three activities now. In that first activity, the sound travel through the table is wood is acting like a medium. In second activity, here we took metal strip. So here the sound travel through the metal strip, that metal is acting like a medium. In third activity, the sound travel through the thread. Okay, so the thread is acting like a medium. Does sound travel in liquids? Can we hear the sound produced in water? Let us find out. So, in previous topic we discussed about the propagation of sound in solids. So, does sound travel in liquids? Can we hear the sound produced in water? Let us find out. So, what is our activity name? Propagation of sound through liquids. So to perform this activity we need 2 tumblers and stones. Water. Take 2 tumblers, fill it with water and take 2 stones and strike them against each other, keeping your hands inside the water. Okay, so take a tumbler, fill it with water. Okay, next take 2 stones and strike them each other, keeping your hands inside the water. So here in first tumbler we kept our two hands with stones inside the water and we rubbed each other. Like that we should do now. Okay, okay, so ask your friend to listen to the sound produced by keeping his ears touching the walls of the tumbler. Okay, when you are making the sound inside the bucket with the help of stones, you ask your friend to listen to the sound produced by stones by keeping his or her ears touching the walls of the tumbler. Ask your friend about the difference between the sound produced by striking the stones each other in water and striking them air. Okay, so here in first figure we kept our two hands inside the water and we rubbed the stones each other. Okay, so in second figure, here we are not immersed our hands inside the water, so here we kept the stones outside the water, means in air we kept. Okay, and we rubbed each other. Okay, so ask your friend about the difference between the sounds produced by striking the stones against each other in water and striking them in air. Thus the conclusion is that the sound propagates through the matter in all the three states: solid, liquid and gas. So here first we took one bucket and filled it with water, and we took two stones and we strike that stones each other by keeping our hands inside the water, and we asked our friend to listen to the sound by keeping his ears touching the walls of the bucket. Okay, so he heard the sound. This proves that the sound propagates through the liquids. Okay, he hears the sound. This proves that the sound propagates through liquids. Does sound travel in liquids? Yes, sound can travel in liquids. Can we hear the sound produced in water? Yes, we can hear. And in second figure we kept the stones in open air outside. Okay, next we rubbed each other. So ask your friend to about the difference between sound produced by striking the stones against each other in water and striking them in air. So in air also we can listen the sound. Thus the conclusion is that the sound propagates through the matter in all the three states: solids, liquids and gas. So sound propagates through the solids we discussed with some activities. Okay, Next, with the help of buckets and water also we rub out the stone. Then also we heard the sound. So by that activity we can say that the sound propagates through the liquids. And next, we kept the stones outside in air and we rubbed each other. That time also we heard the sound. So by these three activities we can say that the sound propagates through the three states of a matter. What are the three states? Solids, liquids and gases. So by the three states the sound can travel from one place to another. Does the sound travel if there is no medium? Now we are discussing one more topic. Does the sound travel if there is no medium? Okay. So does the sound travel if there is no medium? That we discuss with one activity. First, take a water tumbler or glass made up of a plastic or glass. Okay. So first take a water tumbler or glass. So that is made up of plastic or glass. Make sure that the tumbler or the glass is dry. It should be long enough to accommodate a cell phone vertically. So make sure that the tumbler or glass is dry. So it should be long enough to place a cell phone vertically in that. Now place a cell phone small in size in the glass and play the ringtone of the mobile. Listen to the ringtone and its volume level, and cover the glass with a small plate and again listen to the ringtone and note the difference in these volumes of the sound. Now suck the air from the glass by keeping close to your mouth as shown in the figure 15. If you suck air quickly, the rim of the glass will stick around your mouth due to the air lag. Now listen to the volume of the ringtone at this stage and also ask your friend to listen to the sound for comparing the variation in its value. Is there any change in the volume of the sound observed by you or your friend? Okay. First take a glass or plastic tumbler and make sure that the glass tumbler is dry and it should be long enough to accommodate a cell phone vertically. Okay. Now place a cell phone small in size in the glass and play the ringtone of the mobile and listen to the ringtone and its volume level. Okay, we can listen the sound now. Now cover the glass with a small plate and again listen to the ringtone and note the difference in the volume of the sound. So when we cover, okay, now cover the glass with the help of plate. Again listen the sound and observe the difference in the volume of the sound. Now suck the air from the glass, keeping it close to your mouth. If you suck air quickly, the rim of the glass will stick around your mouth due to air lag. Okay, so now suck the air from the glass by keeping it close to your mouth. Okay, if you suck the air quickly, the rim of the glass will stick around your mouth due to air lag. Now listen to the volume of the ringtone at this stage and also ask your friend to listen to the sound for comparing variation in its value. Okay, so what difference did you observe in these three stages? First time we place a cell phone in the glass and we listen the sound, more sound will come. Second stage we cover the glass tumbler with the help of plate, so that time the sound volume is decreased. Third time we suck the air by keeping the glass close to our mouth, then the glass stick to our mouth due to air lag. That time listen to the sound, it will be decreases. Okay, so is there any change in the volume of the sound observed by us? Okay, when the tumbler is covered with a plate, the volume reduces but you can hear the ringtone. Okay, so when the tumbler is covered with a plate, the volume reduces but we can hear the ringtone. And as we start sucking more and more air, we can notice that the volume decreases gradually. Okay, and if the air is sucked completely, you will not hear the sound at all. Okay, so when we suck the air with the help of our mouth, we can observe that the volume decreases gradually, and if the air is sucked completely, you will not hear the sound at all. Okay, but practically it is not easy to us. Okay, so this activity gives an idea about the need of a medium for the propagation of sound. Okay, so when we suck the air from the glass, we cannot hear the sound. When we suck the air completely with the help of our mouth, we cannot hear the sound. Okay, so we are sucking the air from that, means there is no medium in that. Okay, so that's why we cannot hear the sound, but this is not easy to us. Okay, so by this activity we can prove that sound need a medium for the propagation for its propagation. Okay, if there is no medium, the sound cannot propagate. How do we hear the sound? We hear the sound produced in our surroundings with the help of ears. Okay, so we hear the sound with the help of our ears. The structure of ears play an important role in hearing the sound. Okay, so let us peep into our ear and try to understand how we hear the sound. So our ear play a very important role in hearing the sound. Now we will discuss about the structure and functioning of our ear. Structure and functioning of the eardrum. Our ear consists of three sections. The outer ear, the middle ear and the inner ear. Okay, so our ear consists of three sections, that are outer ear, middle ear and inner ear. Pinna of the external ear collect the sound vibration. Okay, so the pinna of the external ear collect the sound vibrations. They enter into the ear canal. Okay, they enter into the ear canal. We have learned that the sound travels in the form of vibrations. We know that the sound travels in the form of vibrations. These vibrations strike the eardrum and make it to vibrate. Okay, so these vibrations strike the eardrum and make it to vibrate. Okay, so the vibrations from the eardrum reach the middle ear. Okay, it contains three small bones. They are malleus, incus and stapes. Okay, so they magnify the sound vibrations. Okay, so the vibrations from the eardrum reach the middle ear. This contain three bones. Okay, they are malleus, incus and stapes. Okay, these stapes transmit the vibrations to the membrane of the oval window. The oval window has the surface area 1/20th of the eardrum. By this, the vibrations increases 30 to 60 times. The vibration from the oval window transmit to the cochlea, which is the inner part of the ear. Next, the cochlea is filled with a fluid which transmit the vibrations. Okay, the motion of the vibrations in the cochlea is detected by the tiny hairs connected to nerves at this point. So the vibrations are transformed into the electrical signals and carried by the nerves to the brain, where the sensation of the sound is realized. Okay, so the sound vibrations can also reach the inner ear by traveling directly through the bones of the skull as you tap your head. So our ear consists of three sections. They are outer ear, middle ear and inner ear. Okay, pinna of the external ear collect the sound vibrations. They enter into the ear canal. Okay, and we have learned that the sound travels in the form of vibrations. So these vibrations strike the eardrum and make it to vibrate. Now the vibrations from the eardrum reach the middle ear. It contains three small bones. They are malleus, incus and stapes. So they magnify the sound vibrations. The stapes transmit the vibrations to the membrane of the oval window. Okay, now the oval window has the surface area 1/20th of the eardrum. By this, the vibrations increase 30 to 60 times. Now the vibrations from the oval window transmit to the cochlea, which is the inner part of the ear. Okay, the cochlea is filled with the fluid which transmit the vibrations. So the motion of the vibrations in the cochlea is detected by tiny hairs connected to nerves at this point. So the vibrations are transmitted into the transformed into electrical signals and carried by the nerves to brains, where the sensation of sound is realized. Okay, the sound vibrations can also reach the inner ear by traveling directly through the bones of your skulls as you tap your head.